We build our entire modern civilization on incredibly fragile orbiting satellites and delicate electrical transmission lines, actively ignoring the terrifying reality that our sun routinely fires off massive, supercharged magnetic bombs called cannibal CMEs.
Tracking the fallout from the June 4th and 5th event reveals how a solar temper tantrum 93 million miles away directly manipulates the electricity in your local power grid. It literally paints the night sky with glowing radiation, too.
NOAA originally forecasted a G3 strong event, which, ultimately struck our atmosphere as a G2 moderate storm.
Tracing the origin of this specific storm requires looking back to June 2nd. A highly volatile region of the sunspot, AR3697, became violently unstable. Magnetic fields within the sun's corona constantly twist, snap, and realign under immense physical pressure.
Snapping those magnetic field lines violently expels billions of tons of superheated solar material directly into the vacuum of space.
NASA ranks these solar flares on a rigid classification system. The lower end features the relatively minor B-class and C-class flares.
Moving up the scale brings you to the significantly stronger M-class eruptions.
Reaching the top tier introduces the massive X-class flares. An X-class carries 10 times the raw energy output of an M-class eruption and a full 100 times the destructive energy of a baseline C-class event.
Wait, a full 100 times the energy? Firing off an X-class flare means the sun is releasing the energy equivalent of millions of nuclear weapons detonating simultaneously.
Launching 2 consecutive M-class flares followed almost immediately by a massive X-class flare within a single 24-hour window sets a highly dangerous stage. Launching 3 distinct coronal mass ejections in such rapid succession guarantees they will interact in transit.
Calling it a cannibal CME sounds like a mystical event from a bad science fiction movie. Frame this as a cosmic demolition derby. 2 slow-moving sedans, the first 2 M-class CMEs, are cruising down the highway.
A speeding semi-truck, that faster X-class CME, comes roaring up from behind, rear-ends the sedans, and creates a massive combined wreckage hurtling directly toward Earth's windshield.
Catching up to preceding plasma clouds requires staggering kinetic energy.
That third eruption on June 2nd wasn't just fast.
It was moving fast enough to literally swallow the first 2 whole.
Consuming the slower material ahead of it fundamentally alters the physics of the wave. The magnetic fields of all 3 independent ejections compress together into a single, highly intensified structure.
Forcing that much solar material into a smaller physical volume drastically increases the density of the charged particles racing toward our planet. The internal magnetic structure of the combined wave becomes incredibly chaotic.
Issuing a strong G3 geomagnetic storm warning based on that merged density triggered a massive defensive response across the globe. Ground-based observations later confirmed a G2 moderate storm level officially hit by Friday.
Hitting that G2 threshold forced power grid operators and satellite engineers to execute a wave of silent stress tests across our entire technological infrastructure.
Hearing vague warnings about voltage corrections keeps the threat entirely abstract. Abstract statistics do not make people look up from their phones.
Going grocery shopping feels entirely normal until the checkout system crashes. A local power grid triggers phantom false alarms. Operators frantically balance transmission loads to prevent sudden blackouts in your specific neighborhood.
A delivery driver's GPS suddenly misplaces them by 3 streets because a blast of solar plasma degraded the low-frequency radio signals passing through the atmosphere.
Degraded radio signals present a severe, immediate hazard for the aviation industry.
High-frequency radio communications experience sudden, unpredictable degradation exclusively on the sunlit side of the Earth during these bombardments. Commercial pilots flying transoceanic routes and maritime operators navigating vast shipping lanes face complete losses of radio contact.
Relying on secondary backups mid-flight over the Pacific Ocean sounds like a massive vulnerability that the threat extends far beyond the surface of the planet.
Spacecraft operating in low Earth orbit face immense physical drag when a geomagnetic storm actually hits. The Earth's atmosphere literally heats up and expands outward when slammed by the kinetic energy from a cannibal CME.
Encountering thicker atmospheric resistance where there was previously a cold vacuum alters how every single satellite moves. Increased physical drag changes their carefully calculated orbital trajectories.
Ground control teams must manually calculate the new drag coefficient, fire the onboard thrusters, and make emergency orientation corrections just to keep hundreds of millions of dollars of hardware from falling out of the sky.
We saw this exact scenario play out in 2022 when an unexpected storm caused dozens of newly launched commercial satellites to experience so much drag they burned up in the atmosphere.
Spending massive amounts of capital launching a satellite just to have it knocked out of orbit by a pocket of hot expanding air highlights the sheer fragility of our orbital networks. Surface charging presents an entirely different, equally massive vulnerability for these satellite components.
The intense bombardment of charged particles causes invisible static electricity to build up rapidly on the exterior solar panels of spacecraft. Building up that static charge creates a severe risk of electrostatic discharge.
A single spark jumping across a circuit board can permanently fry the sensitive internal computers controlling the satellite.
Losing precision telemetry data plagues these orbital assets throughout the entire duration of the storm. Engineers sitting at command centers experience terrifying intermittent tracking problems.
Flying multi-million-dollar assets blind while waiting for the magnetic interference to naturally subside forces them to run predictive models just to guess where their satellites are actually located in orbit.
We hear these apocalyptic warnings from NOAA all the time. The internet didn't collapse on June 5th. Satellites aren't raining down on our heads in burning heaps. Are scientists just crying wolf here?
Assuming researchers are overreacting ignores the sheer volume of frantic mitigation happening behind the scenes. The impacts remain completely silent to the public purely because engineers are pulling mandatory all-nighters to prevent a total grid failure.
Geomagnetically induced currents flood the transmission lines with direct current. Our power grids are built entirely for alternating current.
Forcing direct current into massive industrial electrical transformers causes their magnetic cores to saturate.
Saturating the magnetic core of a massive piece of industrial hardware sounds like an engineering nightmare.
Saturated magnetic cores heat up incredibly fast. Technicians actively fight these phantom direct currents by manually rerouting massive amounts of power in real time.
Failing to reroute that power fast enough physically melts the copper windings inside the transformer under the sudden surge of unpredictable energy.
Rerouting high-voltage power in real time sounds like playing a high-stakes video game with the actual power grid. The entire system survives a G2 or G3 event purely because thousands of people manually override automated safety triggers currently being tricked by solar radiation.
We operate a global civilization on the razor's edge of total technological failure.
Monitoring these invisible threats requires a vast array of specialized space-based instruments constantly observing the sun. Forecasters at the Space Weather Prediction Center rely heavily on the Boulder magnetometer, real-time solar wind data from the Advanced Composition Explorer satellite, and the GOES solar ultraviolet imager.
Providing the critical 30-minute warning time necessary for operators to protect their networks depends entirely on this continuous stream of orbital data. The sheer scale of the federal monitoring effort proves the magnitude of the danger.
NOAA maintains dedicated, real-time dashboards for aviation, electric power grids, global positioning systems, and radio communications. An entire governmental infrastructure exists solely to monitor space weather.
The threat to our fragile technology remains persistent, severe, and entirely out of our direct control.
Funneling that superheated ionized gas toward the magnetic poles initiates a massive transfer of kinetic energy. The magnetic field of the Earth acts like a massive shield, catching the charged plasma from the CANNIBAL CME and redirecting it down toward the North and South poles.
That same ionized gas causing engineers to panic at the command centers creates an entirely different phenomenon when it slams into the upper atmosphere. It creates the aurora borealis.
The plasma slams violently into the atoms and molecules floating in Earth's upper atmosphere. These incoming ions become physically trapped in the ionosphere, roughly 60 to 80 miles straight above the surface of the planet.
Trapping those ions high in the atmosphere turns the sky into a massive visible science experiment. Collisions between the incredibly fast solar particles and the relatively slow atmospheric gases transfer immense amounts of physical energy to the atoms.
The electrons inside the atmospheric atoms become highly excited and jump to a higher energy state. Returning to their normal state forces them to release that excess absorbed energy in the physical form of photons.
Releasing those billions of tiny photons causes the entire night sky to glow exactly like a neon light.
Experiencing a geomagnetic storm highlights a bizarre paradox of our highly connected modern world. The intense radiation from a coronal mass ejection remains entirely harmless to biological life walking around on the surface. perfectly shielded by the planet's natural magnetic field.
That exact same radiation is highly toxic to the silicon microchips and electric grids we depend on for daily survival.
The aurora borealis functions as nature's prettiest, most distracting warning label. We romanticize the constantly changing streams of brightly colored light.
We stand outside in our driveways with our phone cameras, while our orbital satellite infrastructure is actively fighting off a targeted radiation bombardment just a few hundred miles above our heads.
Forecasting the exact geographical visibility of these auroras relies entirely on predicting the intensity of the incoming magnetic storm. Predicting the density and speed of the solar wind allows forecasters to calculate exactly how far the auroral oval will expand outward from the poles.
NOAA predicted the G3 conditions for the June 4th and 5th event would push the northern lights deep down into the mid-latitudes. The official forecast indicated high visibility in states like Illinois and Oregon.
Pushing the aurora that far south requires a massive, sustained influx of solar energy. Viewing the phenomenon with the naked eye requires specific, highly optimized local conditions.
The optimal window for maximum visibility generally falls between 10 p.m. and 4 a.m. local time. Observers must travel to the darkest possible geographic location, driving far away from the blinding light pollution of major metropolitan cities.
Experiencing a moderate G2 or a strong G3 storm puts on a highly visible show for the entire northern half of the country. Expanding the auroral oval drastically happens rapidly under severe G4 or extreme G5 conditions.
Pushing the glowing atmospheric plasma closer to the Earth's equator completely upends the traditional scientific understanding of exactly where auroras can physically occur.
Historical data from recent severe storms demonstrates exactly how far south these atmospheric disturbances can actually reach. Northern lights have been clearly documented lighting up the sky over northern California and Alabama during rare G4 events.
Florida residents actually witnessed the northern lights multiple times in recent years. Brilliant, shifting displays of color dominated the skies over North and Central Florida in May 2024 and November 2025.
Different atmospheric gases produce the specific, highly vivid colors reported during those rare southern sightings. The altitude and the specific type of gas involved determine the exact wavelength of the emitted photon.
Oxygen atoms floating lower in the atmosphere typically emit the bright red and vivid green light. Nitrogen molecules sitting at different altitudes are directly responsible for the pink, blue, deep purple, and violet hues that completely dazzle casual observers standing on the ground.
Tracking a constantly shifting set of statistical probabilities defines the modern science of space weather prediction. Forecasters maintained a firm 50% probability for minor to moderate R1 and R2 radio blackouts for the June 6th through 8th window immediately following the initial storm.
The sun emitting electrically charged particles creates a beautiful, highly photographed light show for people standing in their driveways in Florida. That exact same event simultaneously threatens to trigger cascading false alarms on the critical protection devices of their local power station.
The June 4th and 5th event served as a perfect physical demonstration of the mechanics driving space weather. A highly active sunspot fired off 2 consecutive M-class flares and a massive X-class flare.
Launching 3 distinct coronal mass ejections caused them to merge in transit to form a massive CANNIBAL CME.
Striking the Earth's atmosphere with this combined wave of solar plasma and magnetic fields triggered a G2 moderate geomagnetic storm. Triggering that storm initiated a massive, entirely silent stress test for our fragile orbital and terrestrial technology, while simultaneously providing a spectacular neon light show for the mid-latitudes.
If an X-class flare and a 3-part CANNIBAL CME only resulted in a G2 or G3 storm requiring minor grid corrections and temporary satellite adjustments, what happens when a vastly larger eruption scores a direct hit? Are we building an entire civilization completely dependent on technology that fundamentally cannot withstand a bad day on the sun? Yes. Goodbye.